All right, so this is lesson 1.1, evaluate expressions. A variable is a letter used to represent one or more numbers. It's kind of like a placeholder. And usually we're going to be solving to find out what that variable could be. Somebody give me an example of what could be a variable? Like what letter?
X.
A, X, Y. Variables can be any placeholder. Pi is often, although that's not really a variable because it stands for a really big number. But yeah, they can use just about any letter of the alphabet. Typically they use X right at the beginning, but later on you'll start seeing a whole lot more. Okay, what's an algebraic expression?
It's an expression that includes at least one variable.
That's right. So, and then the word expression tells you that there's no equal sign. So an expression would be like 5x, because we can't solve it. It's just part of an equation. An equation always has that equal sign, hence the word equation. So if this is an algebraic expression, and they used n, so let me put n on here. What does this mean? 5 with the letter n next to it. What kind of math is this? You guys remember? When you have a number next to a letter, it means multiplication. So this would be 5 times n. Okay?
You have to write that?
Yes. Anything I write up here, you write. All right, let's look at the next expression. We have 14 over y. What kind of math is being done in this expression?
Division.
Division, very good. So it's like saying 14 divided by y. It's another way to say that, which is division. Good. All right, let's look at we have 6 plus c. What kind of math is being done here? All right, we got to the easy ones. Addition. And the last one, 8 minus x, which is subtraction. That's right. The number one expression I really want you to pay attention to is when you have a number next to a letter. You're going to see this so many times, and you need to look at that and think that's multiplication. Okay? The addition and subtraction is pretty simple, and then when you have a number over a letter, that it does make sense that that's division. So this is the one you got to teach yourself. All right, so let's do example 1. Make sure you're in your journal. We're going to evaluate the expression when the n in the expression equals 3. So for A, we have 13 times n, and they want us to solve. So if they're telling me that n equals 3, where do I plug in this 3? Right where the n is. So I'm going to say 13 times 3. What is 13 times 3? 39. All right, for B, we have 9 over n. Again, they told me that n equals 3, so where am I going to plug in that 3? Right there where the n is, so I'm going to have 9 divided by 3, which is 3. 3 times 3 is 9. Yes. Good. I'm trying not to turn page till you got it written down. If I ever go too fast, you just tell me to stop. I don't have a problem. All right, let's look at C. We have n minus 1. So I'm going to rewrite that, plugging in the 3 where the n is. So I wrote a 3 here. I said it, but I wrote the wrong 3. So then I have 3 minus 1, which is 2. And my last one, we have n plus 8. So I'm going to rewrite it because they told me originally that n equals 3. So I'm going to say 3 plus 8 which is 11. Remember, if your papers are really messy, please square or box your answers so that I can find them quickly. If it's written neatly, I can find it, no problem. All right, any questions on these? Do you want to do any more practice on this kind? Kim has a quizzical look. Okay?
Yeah, I got it. Okay.
Okay, good?
Yeah.
Let's look at example 2. So now we're looking at a word problem. The total cost of seeing a movie at a theater can be represented by the expression A plus R. Whenever you're dealing with word problems, as soon as you hear something that's math, write it down. Where A is the cost in dollars of admission, and R, this is admission, woo, and R is the cost in dollars of refreshments. So I make myself little notes about what these variables mean. Suppose you pay $7.50 for admission and $7.25 for refreshments. Find the total cost. So can we make an equation now? Yes. We're trying to find the total cost. How would you find the total cost? You're going to add the admission plus the refreshments, right?
Yes.
So now I have an equation. Now let's plug in the numbers that we know. Well, we know that A was what? $7.50. And refreshments was $7.25. So I'm going to say total cost is $7.50 plus $7.25. So then my total cost is $14.75. Am I finished? This is a word problem, so there's one other thing I need to do, which is label it, which this one's easy because it's money, so I just put a big old dollar sign in front. Good. Any questions?
No.
You're good. No, you're fine.
Okay.
All right. So now let's talk about expressions using exponents. Do you guys remember what an exponent is?
Yeah.
It's the little number next to a big number, right? This is an exponent. Please put this in your journals. Draw this. Okay, and then what's the big number called?
Denominator?
Nope.
No.
Look in your books. Page 3. The big number is called the base. Okay, and then this whole thing, this whole would be called a power. You'll hear me often say 3 to the power of 4. Okay, that's another way you can describe what this expression is doing. So, what kind of math is this saying?
Multiplying.
It's multiplication, but the trick is it's multiplication of the base times itself, however many times the exponent says. So the exponent says we're multiplying 3 times itself 4 times. So that's like saying 3 times 3 times 3 times 3. So you would go 3 times 3, which is 9, times 3, which is 27, times 3, which is whatever 27 times 3 is. I can't do that in my head. That's fine. You get the point. The cool thing is on your calculator, it'll do this for you. So you plug in 3, and then often it's an arrow that looks like this to the power of 4. Button. Okay? You hit 3, hit the YX, and then put 4. Lame. All right, sorry, my screen turned off. Sorry about that. Good? Okay, so those are the 2 possible buttons that you'll see on your calculators. Okay, those mean to the power of or exponent. All right, let's look at example 3. We're going to write the power in words and then as a product, meaning we're going to solve it. Oh, no, we're going to set it in the equation as if it's multiplying itself. Sorry, not solve it. So the first one is 7, like this. How would you say that in words?
7 to the power of 1.
Yes, there's 2 different ways you can say it. 7 to the power of 1 or 7 to the first power. Both of those work. Write that down. 7 to the power of 1 or 7 to the first power. Okay, and then how would I write this as a product? Like without the exponent.
7 to 7.
No, it's just 7 because there's only 1. That exponent tells you how many there are. All right, let's do B. All right, how would I write this one?
5 to the power of 2.
Yes. 5 to the power of 2. So another way you can say that. There's actually 3 different ways you can say this one. 5 to the second power. Or 5 squared. So there's 3 different ways you can say this one. Okay, and how would I write that as a product?
10. Oh, that.
Yeah, because there's 2 of them. 5 squared means there's 2 of them, so 5 times 5. All right, let's look at C. Okay, how would I write this one? That's a terrible number up there. This is supposed to be a 3. There we go. Okay, so how would I write this one?
1/2 to the power
1/2 to the power of 3. Is there any other way I could say it? 1/2 cubed. Those are the only 2 that have shortcuts. 5 squared and cubed. All right, so how would I write this as a product? Right, 1/2 3 times. 1/2 times 1/2 times 1/2. Good. All right, we have one more. So this one is, okay, how would I write this one?
Z to the 5th power.
Very good. Z to the 5th power. The only other way to say that is Z to the power of 5. Either way works. Okay, and then how do I write that as a product? Z times Z times Z times Z times Z. The reason I put this little tick mark in the middle is because sometimes people's Z's start to look like 2's. So if you ever see this little line in the middle, that's the old school way of saying that's a letter, not a number. So, because sometimes, when we were doing that the other day, we were putting in codes for the computer, and I wrote a Z, and they thought it was a 2, so they couldn't get in. I was like, well, that's my handwriting, sorry. All right, any questions on those? Awesome. Let's look at example 4 on page 4 of your textbook. Animated over there. I love it. All right. So we have x to the power of 4, and it wants us to evaluate that when x equals 2. So what does that mean? Evaluate it when x equals 2. What am I going to do?
It says when you actually put the 2.
Yeah, I'm going to take this 2 and I'm going to put it where that x is. So 2 to the power of 4. I can write that as what? 2 times 2 times 2 times 2, which is, you can do it on your calculator, or you can go 2 times 2 is 4, times 2 is 8, 8 times 2 is 16. So that's your final answer. Your mom's going to spoil me, Sophia. All right, for B, we're evaluating n to the power of 3 when n equals 1.5. So that's the expression. How do I change it to solve it? That's good. 1.5 to the power of 3, which is the same thing as saying 1.5 times 1.5 times 1.5. This is not one I can do in my head. So either grab your calculator or be sneaky and look at the textbook that already tells you the answer. 3.375. So on your calculator, you could do it two ways. I could say 1.5 times 1.5 times 1.5 on my calculator. Or I could say 1.5, find that little exponent button, press that, and type in a 3. I would recommend if you get used to the exponent button, that's the one you use, because sometimes you're going to have 5 to the power of 21. You're not going to want to hit the 5 21 times. So find your exponent button and get used to it. All right, I believe that's it. You guys know what you're doing. I don't have to do the last example. So it's in your Google Classroom. You're actually doing 2 different IXLs, which I cannot remember off the top of my head. So look in your Google Classroom, 2 IXLs.
I thought we were doing like the exercise.
We are. I wanted to start off with an IXL this week. Like I said, I think I'm going to cancel IXL. I'm not sure.